Oh, this time it really is working. Right, so we are now live on YouTube. We're not live, don't worry. Okay. So this is question 2 about the factor remainder theorem. It says the cubic polynomial is defined as being 2x cubed plus 3x squared minus 17x plus 6. Find the remainder when it's divided by x minus 3. Now, remember, don't get drawn into seeing the word divided and think, we have to do long division. For 2 marks, we really don't have to do long division. All that we want from us is to find the remainder, and that's the remainder theorem that we just wrote down. So to do that, the remainder would be what you get if you sub 3 into the function. So it's just f of 3. That's all there is to it. So we put 3 in, 2 lots of 3 cubed, plus 3 times 3 squared, minus 17 times 3 plus 6. We moved on from core 1 that you were doing this morning. We are now allowed a calculator, so we can put them into the calculator. I haven't got one with me, so who needs a calculator? 54, maybe, plus 18, minus something like 51. Sorry? Is it 51? Plus 6.
It's not 18.
It's not 18.
7.
What's going on? Oh yeah, it's 27, yeah. Disastrous 9 times table. Right, and then if we work this out, we're going to get 36. Go with 36. There we go. So for 2 marks, that's all you wanted to do. Now, part 2, given that f of 2 equals 0, what does that mean? F of 2 equals 0 instantly tells us x minus 2 is a factor. Brilliant. So we've got that. Express f of x as the product of a linear factor and a quadratic factor. Right. If you love long division, now's your chance. But you still don't have to do long division. What we've just been told is that the function, which was 2x cubed plus 3x squared minus 17x plus 6, is equal to the product of a linear factor. Now we've just said that bit tells us the linear factor is x minus 2, and a quadratic factor, which at the moment we don't know what it is. Now this is where you could use long division to work it out, but you don't have to. Because if you think logically about this, when we multiply out these 2 brackets, the only way we can get 2x cubed is by doing x times this term here. So this term must be 2x squared. If you did long division, that's what you start off with. At the other end of the bracket, the only way we can get this plus 6 here is by doing this minus 2 times whatever number is hanging around at the end here. Now minus 2 times minus 3 would give us plus 6. So just by using a little bit of logic and common sense, we can get those 2 points. Now let's think about elsewhere in here. To get 3x squared, the only way we could do that is by doing the minus 2 times the 2x squared there, and x times whatever we get to put in the middle. Now we need to end up with plus 3. Minus 2 times 2 would give us minus 4. So somewhere we need to find another 7x squares. So that must be a plus 7x in the middle to generate the 7x squared. Now we can check this, because look, we've got minus 17x here, and that minus 17 must come from x times minus 3 and minus 2 times the 7. And minus 2 times 7 is negative 14. Another minus 3 would give me negative 17. That must be right. Now, you can do long division if you want the safety net of going through long division for that. But I think that's so much easier, isn't it, to work it out that way. And just kind of think through what it would be like. Now, if you've not done it that way before, I don't know if everybody has, if you've not done it that way before, try and look back, find some of the questions that you've factorised using long division, and just work through in your own mind how you can do it that way. It saves you so much time and gets you all 4 of the marks that you need. So we've got, I'm just going to write that again so it's shown quite neatly. We've got x minus 2, 2x squared plus 7x minus 3. We don't need to try and factorise that because it said the product of a linear and quadratic factor. Part 3 said determine the number of real roots of the equation, giving a reason for your answer. Okay. Well, let's think about what we've got. We have one real root for certain. X equals 2 is a real root. How many real roots does that have? Well, what's the way of telling how many roots a quadratic factor has? Begins with D. Ends with ant. Has discriminants as the whole thing. Yes, that would be it. We just need to do the discriminant. So this would be, if we consider that bit, the discriminant b squared minus 4ac is 7 squared minus 4 times 2 times negative 3. Now I know the only thing we really care about is this positive or negative? But actually, I think we should actually show the value that we get, just to demonstrate that we've probably worked it out. So this is going to be 49 plus, what is that, 24? Which gives us 73. And the important thing is that that is bigger than 0. So this quadratic factor has 2 real roots. The linear factor is a 3rd real root. Therefore, 3 real roots of the equation. And that will be it done. Okay. One thing I want you to remember, sometimes people will just write things like b squared minus 4ac is bigger than 0, therefore 3 real roots. But the examiner wants to see that you have actually done the calculation. So it doesn't take long to do it, actually, right through. Okay? You need to be ready to turn off the camera at the end of the question as well by pressing the red button again, as I say, and that's maths.
No.
Yeah, no.